find C given that P at 3 minus 2, Q at 4C, and R at minus 110 are collinear. So collinear means they all lie on one straight line. And if you think about 3, I'm not going to bother to try and space these out properly according to scale. But let's just say this was the line, and I'll say it again, this is in no way a representation of these points in order. But if they're all collinear, they're all on one line, so it might look something like this, right? So that being said, it means that PQ, the gradient of PQ, will be exactly the same as the gradient of PR, which will be exactly the same as the gradient of QR. All three things that I could find a gradient between, so from here to here, from here to here, or the whole bit, has exactly the same gradient, and that's what we do to find the same thing, and you actually get choices. So I could say, I could find the gradient of PR. That's the only one I can definitely find, because I have the x and y coordinate of P and I have the x and y coordinate of R. So let's find M of PR. So hopefully you know by now that M equals y2 minus y1 over x2 minus x1. If you don't, learn that formula. It's a gradient between 2 points, a straight line between 2 points, and you need to know it, and it will not be given to you. So MPR is going to be well, y2 minus y1. So y2 is the y coordinate of R, which is 10. y1 is the y coordinate of P, which is minus 2. So y2 minus minus 1 minus minus 2. x2 minus x1, so the x coordinate of the second point R is minus 1, minus the x coordinate at P is 3. So that must be 10 minus minus 2 is 12, minus 1 minus 3 is minus 4, so that is minus 3. So this is definitely a bad representation, because the actual line is more like this. So your actual line is a line with gradient minus 3, looks something like that. But as far as the principles go, it really doesn't matter. So now you can pick, for Q, we're not going to find C, which is on point Q. Now you can use PQ or QR, and if I was you, I would use the numbers that look the easiest. So I reckon if I use Q as the second point, then I'll start with a C. So I'm going to find MPQ. So MPQ, and we know it equals minus 3, right? So that means that y2 minus y1, so y2 is the y coordinate at Q, which is C, minus y1, which is the y coordinate at P, which is minus 2, over x2 minus x1, the x coordinate at P is 4, minus the x coordinate, so that's the x coordinate at Q, sorry, minus the x coordinate at P, which is 3. And I know that that needs to equal minus 3, so tidy it up. C minus minus 2 is C plus 2. 4 plus 3 is 1, which is really handy, equals minus 3. So that 1 you can just get rid of. So C plus 2 equals minus 3, so C must equal minus 3 minus 2. C equals minus 5. Okay, so for any 3 points that you know are collinear, you know that the combinations of the gradients between any 2 points must be exactly the same, and it really doesn't matter which 2 you pick. So pick the 2 that make your maths the easiest, but if you're confident enough, it really shouldn't make much difference.